Hi, everyone. This is Andrew Choi, a software engineer at companies like Microsoft, LinkedIn, Snapchat, IBM. I'll be your instructor for this course, Software Engineering Interview Prep. If you're targeting a PM role at top tech companies, I would highly recommend you attend this course. This course is absolutely for free. We will cover everything from software engineering to technical interviews to go-to-market strategy. So during this course, I will cover important topics, most asked interview questions, and efficient ways to solve them. I have more than 7 years of experience in software engineering role at top tech companies in the United States, and I've helped a lot of candidates with interview preparations. I'm excited to help you land your dream role, so sign up for the course, and I look forward to meeting you in the coming sessions. So let me give you a quick introduction and overview of HiCounselor. HiCounselor is an online career accelerator that helps job seekers find a full-time job. HiCounselor helps candidates with interview prep as well as getting the interview calls. And we utilize AI-powered job search tool and a strong network of 300 plus employers to help candidates land a job. Every candidate gets a personal attention and mentorships from professionals like myself who come from top tech companies. The payment structure at HiCounselor is income share agreement, where you don't pay anything to HiCounselor until you find a job. So once you land a job, you pay a small fraction of your first year salary in monthly installments. So there's no upfront cost. If you're currently looking for a job, a HiCounselor could be a great resource for you. The next cohort at HiCounselor starts soon. So if you're interested, please apply on HiCounselor.com and feel free to use my code Andrew, ANDREW, and you will get $500 discount for using HiCounselor. So in this session, we're gonna study the topic of arrays, and then we're gonna also do practical interview coding questions together. Okay. So obviously, the arrays are one of the most fundamental concepts and data structures and concept that's really asked by almost every technical interview questions in Silicon Valley. It's used in a wide variety of forms, from just concept questions, as well as practical applications, as well as how you use arrays to solve a complex algorithmic problem in a real world setting. So arrays, essentially, they're used for storing multiple values in a single variable. So instead of declaring separate variables for each value. So in various languages, there are different ways to declare, but in terms of Java, you define the variable type with square brackets, such as strings with a square bracket. So we have created a variable that holds an array of strings. To insert values to it, we can use an array literal, place the values in a comma separated list inside the curly braces in terms of Java. As such. So to create an array of integers, you could do the same thing and declare int array, let's say mynum, and then within the square brackets, within the curly braces, you would include integers. So because the concept is pretty straightforward, we'll dive right into some technical interview questions that utilizes array. So for example, we'll start very simple. The first question is this. Yeah, so the first question is this. If we have cars declared as such, and then we say that cars at zero index is equal to Opel, then what will this system out print line gonna output? Great. So yeah, it's going to be Opel. Now let's try another question. So you're given a sorted array of distinct integers and a target value. So you're going to have distinct integers as well as target value. So you want to basically find the index if the target is found. And if it's not, then you just simply return the index where it would be if it were inserted in the order. So if not, find it. If not found, return the index. Where it would be if it were inserted in the order. And you must write it in O of log n, runtime complexity. So let's try example. Let's say we have 1, 3, 5, 6, and then target is 2, then the output should be 1. Because if it was not found, then we have to find the index where it would be inserted in the order. Okay, so I'll give you maybe 3 minutes to think about it, maybe just approach how you would solve it. You don't have to write the code, but think about how you would approach this. I'll give you 3 minutes. Okay, so there are several ways to solve this. One is utilizing low and high pointer. So essentially, what you do is, let's say you have a solution class, and then inside it, you make a method called insertion, right? And then that will obviously take its array, and then in target. So you're essentially iterating as long as the high pointer is bigger than low. So obviously you need to declare what these pointers are going to be as such, with low being the lowest and high being the maximum value in the array's length. And then in the while loop, you want to set the middle, with the middle being the medium value between the high and the low pointer. So if the array at the middle is equal to target, then we're good. We just simply return the middle value. Now, if that same value is larger than the target, then we update. Then we update the high value to be a little lower, because the target is actually lower than that. And then if the array at middle is, smaller than the target, then we need to up the value of low. And then we simply return the low value. So there's an exception, there's a catch to this. So when you look at the middle, value in here, so if the low and high are extremely big, this line will cause overflow error. So you need to be on a watch out for that. And you can even write a neater code by doing something like this. As such. So in here, we're saying that the low is less than the middle and mid is less than the high. And then in this line, high always decreases, right? Even high minus low is equal to 1. And in this case, the low always increases. So this will be giving you some neater code. All right, so the next problem, we're gonna try something maybe a slightly more, I would say, challenging. So here, we want to find the minimum path sum, where you have like x times y grid filled with a non-negative numbers. So basically, you have some positive integers, and you want to find a path from the top left to the bottom right which minimizes the sum of all numbers along its path. So I'll give you an example. Let's say you have something like this. So you're given an X times Y grid filled with positive numbers, and you want to find the path from top left to the bottom right, which minimizes the sum, of all numbers along its path. And you can only move down or right, because you're going from top left to the bottom right. So for example, let's say you have this. The output is going to be 7, right? Because the path 1, 3, 1, 1, 1, it minimizes the sum. Okay. So there's several ways to reach the bottom right. From like 1, 3, 5, 1, 1. But we chose this path because this is the path which minimizes the sum of all numbers along its path. Okay. So for example, if you were given like input of 1, 2, 3, 4, 5, 6, then the output is going to be 12. Okay. But for this one, it's going to be 7. So I'll give you around 4 to 5 minutes to think about it, and then maybe come up with a, some solution. You don't have to write it, but just think about it. Okay, so let's try this. The question is, going from only south and east, how do we get from the top left to the bottom right? So here, there are many ways to solve this. Obviously, one of them is iteration, just iteratively seeking the way all the way to the bottom right, which has the lowest sum. So there's a couple of ways using dynamic programming and as well as recursion as well. If you do dynamic programming, you need to set up a recursion algorithm first. So when you do recursion to dynamic programming, it makes it possible. So you don't want to. There's nothing fancy or complicated about dynamic programming, and it's something we're gonna cover in the future sessions in HiCounselor. But it's simply that we store and cache the results of every single calculation, such that we don't need to calculate the same result over and over. The whole ideation is pretty similar. We involved an array to store the values, and then we can write the code. So if you write the DPA programming solution, it's going to be very similar to what you get from recursion. The idea is the same. We just reuse the grid to store each sum results to boost the whole process. So that's the difference between recursion and the dynamic programming. But in our case, we're going to write a code for recursion because that's the more intuitive way. So essentially, we start with recursion since it's actually more simple and more intuitive and understandable as a code. So when you think about this issue, you could use a top-down approach. To get the path, you need to travel from the first grid to the grid at the bottom right, which is row -1 and column -1. So you set the grid 0, 0 as the basic case. So this is going to be the base case. This is when we jump out of the recursion. On the other hand, grid at row -1 and column -1 would be the starting point. So we would write a helper method to do the recursion method. And at the beginning point, the method returns the value of the nth cell plus the value of the cell that has less 1. However, we need to consider that things can happen that we reach the first row or column, and we have to make sure that we stay within the array indexes limit. And then at the end, when we reach the first grid, which is grid 0, 0, we're done. So let's try to implement this. And then because we started using the method minimum, we also have to implement a helper method for minimum. So here, we begin with recursion, and then to get the path, we need to travel from the first grid, 0, 0, to grid at here, at the bottom, right? So we set 0, 0 as the base case. So this is when we jump out of the recursion. On the other hand, grid row at -1 and col -1 would be the starting point. And we write a helper method to do recursion work. At the starting point, this method returns value of the cell plus the value of the cell that has less 1. But we need to consider that things can happen when we reach the first row or column, and then we have to make sure that we stay within the array's index limit. So here, the first base case is that this is the exit of the recursion. When a row is equal to 0 and col equals to 0, the return value of that, this is going to be the exit of the recursion, right? So now, for this case, when row is equal to 0, right? Row is anywhere here, but the column is not 0. So here. So we return a grid at the current index plus the minimum of row and column -1. This is when we reach the first row. We will only move horizontally. So because we can only move horizontally, we'll subtract 1 from the column. So it will go from here to here. Now, if the column is equal to 0, meaning we're at the first column, we can only move vertically. So we've decreased the row. And then at the end, we want the minimum sum path. So we pick the cell with the less value, right? So we'll return a grid at the current. We'll return a grid at the current index plus the minimum, the math minimum between the previous row or the previous column. So this is the recursion method when you're trying to solve minimum path summation for this kind of rectangular question. So we'll try one last question, and then I'll give you guys maybe 2 to 3 questions that you could take home and try to solve on your own. So for this question, you have integer array numbers. They're all unique. And you want to find all possible subsets, okay? You want to find all possible subsets, which is the power sets. So the solution set cannot contain duplicate subsets. So they cannot. You can only have a non-duplicate subsets. And you want to return the solution in any order. So for input, let's say you have 1, 2, 3. The output is going to be as such. All right. So you find all the subsets. All right. So I'll give you guys, 4 to 5 minutes to think about how you would approach this question. Okay, I hope it was enough time to think about it. So when it comes to the power set, and you want to find all the subsets, there are several ways: iterative solution, recursive solution, backtracing, bit manipulations, and then there is simple Java's for loop. And for this question, because we haven't tried any for each loops, we're gonna approach this problem with for each loops with no messy indexing. And you can actually avoid some of the concurrent modification exception using a temporary list. So solution is you have return value, a list of integers, obviously. And then you want to find the subsets. So the idea is that we are going from a smaller subset as such, and then we're expanding it with some number like sub 0. And then in the next iteration, we are going to S0, S1, S0, S1, and so forth. So we basically use the method for using for each loops to create a temporary list, and then at each sub result we added a new array to the temporary as well as the I or the X, and then we added all the temporary list to the result, which gets accumulated every iteration, and then we just return the result. So this avoids messy indexing, and we're simply sorting and then looping through the for loop to populate the result list data structure. So I want to leave you with one question, and the question is this: given a x times y grid of characters, and that's going to be called board, okay? And you're also given a string called word, and you want to return true if the word exists in the grid. Again, you're given an xy grid of characters board, and then a string word, and you want to return true if the word exists in the grid. And the word can be made from layers of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. So the same letter cell may not be used more than once. So for example, let's say you have something like this. Let's say you have this, and the board is going to be, A, B, C, E, S, F, C, S, A, D, E, E. And the word is S, E, E, like C, to look at something, C. This is going to return true because we can see that S, E, E is contained in the board, and these are sequentially adjacent cells. So this is the question that I think is a very relevant to very relevant to the array data structure, and I want you to maybe just think about it and then come up with a solution, and we can discuss more. All right, thanks everybody.